It is dark and fog sits on the water. A ship is out past the horizon and the crew cannot see the rocks ahead. Then, far off, a point of light appears. It holds, then fades. A few seconds later, it returns. That single light can be seen from 20 miles away, farther than any bare flame should reach. Tonight we slice a lighthouse open to see how one small lamp is shaped into a beam that crosses the sea. Start with the light itself. Long ago it was an oil flame. Today it is an electric lamp. Left alone, that light does something unhelpful. It spreads. It pours out in every direction at once. Up at the clouds, down at the floor, sideways into the walls. Only a thin sliver ever heads out to sea, and spread that thin, it fades fast. A sailor a few miles out sees nothing. The lamp is not the problem, the waste is. So engineers begin by pinning the light down. The lamp sits at one exact spot, called the focus. The single bright point everything is built around. If we can catch the light leaving that point and bend it all to travel the same way, none of it is wasted. The trouble is the bending. Glass can bend light, but a lens thick enough to grab a whole lamp would be huge, heavy, and would soak up much of the light itself. The answer is the Fresnel lens, named for the French engineer who designed it 200 years ago. Picture a normal magnifying glass, fat in the middle, curved on top. Now slice that curve into a set of thin rings and press them flat, keeping only the surface that does the bending. Throw away the thick glass behind. What is left stands like a wall of concentric rings, light as a window, yet bends light as strongly as the heavy lens it replaced. Watch one ring at a time. Light from the lamp strikes the back of a ring and crosses into the glass. Because the glass is angled just so, the ray bends, the way a straw looks broken in a glass of water. Each ring sits at its own angle, tuned to its distance from the center. A ray heading up is bent back down, a ray heading down is bent back up. Ring by ring, every stray ray turns to face the sea. At the very top and bottom, simple bending is not enough, so those rings are shaped as prisms. They catch light at a steep angle, bounce it once inside the glass like a mirror, then send it forward too. Add it all together, and something remarkable happens. Light that was spilling everywhere is gathered into a single flat beam, narrow from top to bottom, aimed straight at the horizon. The same lamp now looks many times brighter because its light finally pulls one way. Notice that nothing was added to the lamp. We did not make more light, we stopped throwing it away. By folding the wasted rays into the beam, the lens makes a modest lamp appear as bright as a small sun to a distant ship. This is the heart of a lighthouse. A lens does not create power, it aims it. Gather scattered light into one tight line, and that line can travel for miles before it fades into the dark. But a fixed beam points only one way, leaving the rest of the coast dark, so the whole lens is built to turn. In the great old towers, the lens is so heavy it floats in a bath of liquid mercury, which carries the weight with almost no friction. A small motor, or once a falling weight like a clock, turns it slowly. The beam sweeps around the horizon like the hand of a clock, brushing past every ship in turn. Now stand on that distant ship and watch. You do not see a beam sweeping, you are too far for that. You see the light only when the beam points straight at you. For a moment it is there, bright and steady. Then it swings past, and you sit in shadow until it comes back around. A smooth turning beam, seen from far off, becomes something simple. A flash. On, then off, then on, in a slow and steady rhythm. Here is the clever part. Every lighthouse turns at its own pace and groups its flashes its own way. One blinks once every 10 seconds, another gives 2 quick flashes, then a long pause. A third glows steady with a single eclipse. This rhythm is called the light's character, and no 2 neighbors share one. The lighthouse is not only warning that danger is here, it is signing its name in light so anyone watching can tell which light they see. On the ship, the navigator does the rest. She times the flashes with a watch, say 1 every 15 seconds, then finds that pattern printed beside a dot on the chart. Now she knows which lighthouse is speaking and where that light stands on the coast. One known point, fixed on the map, is enough to pull a rough guess into a real position. The dark coastline becomes a place with corners and names, all from one blinking light. Most lighthouses run on their own now. The oil flame became an electric lamp, and many lamps are now LED arrays, sipping power from solar panels and batteries. Ships carry GPS, which can place them within a few steps. Yet the lights still turn, still flash their old characters, because satellites can fail and screens go dark. But a steady light on a rock asks nothing of you. You only have to look up and count. So here is the whole path, from spark to ship. A lamp sits at the focus, spilling light everywhere. A Fresnel lens, built from rings and prisms, bends and bounces every stray ray into one flat beam. Concentrated, that beam reaches far across the water. The lens turns, so the beam sweeps the horizon. From a distance, that sweep reads as a flash. The timing of those flashes is a name, and a sailor, counting in the dark, reads it and knows where she is. One small light folded into a beam, turning patiently through the fog. It does just one thing all night long, telling every ship still out there, this is where the danger ends and the way home begins.